I will discuss certain oxidation rules which play a significant role in assigning the oxidation numbers of an atom. We assign the oxidation number of an atom to find out whether the atom loses electrons or gains electrons in a chemical reaction. Let me start with the first rule, that is the oxidation number of a neutral atom is always 0. Neutral atom is an atom which does not carry any charge. For example, sodium atom is a neutral atom. It does not have any charge. It is in uncombined state. Well, you can have some more example: potassium, calcium, aluminum, boron, and phosphorus, carbon, oxygen, nitrogen. These all individual atoms are neutral atoms. They do not carry any charge. We can assign 0 oxidation number for all these atoms. They have 0 oxidation numbers. Well, let me take one example here. Aluminum metal reacts with H2SO4, sulfuric acid, to produce aluminum sulfate and hydrogen gas. In this reaction, aluminum metal is a neutral atom. It is in uncombined state. That's why we can assign 0 oxidation number for aluminum atom in this chemical reaction. The next rule is the oxidation number of a molecule made up of same type of atoms is always 0. Molecule, you can take one example, that is hydrogen gas. Hydrogen gas, it is made up of only hydrogen atoms. It is a pure gas. Therefore, it has a its oxidation numbers as a 0. We can have some more examples like a nitrogen gas, oxygen gas, fluorine gas, chlorine gas. We can have Br2 molecule. We have I2. These all individual molecules are made up of their respective atoms. For example, oxygen gas, it is made up of only oxygen atoms. Nitrogen gas, it is made up of only nitrogen atoms. So that's why we can assign 0 oxidation number for all these molecules. Let me take one example, that is a combustion reaction in which a hydrocarbon methane CH4 reacts with oxygen molecule to produce carbon dioxide and water molecule. In this reaction, O2 is a molecule which is made up of only oxygen atoms. That's why we can assign 0 oxidation number for oxygen gas in this reaction. Well, the next rule is the total oxidation number of atoms in a neutral compound is always 0. Neutral compound is a compound which does not carry any charge. For example, sodium chloride, it does not have any charge. Sodium has +1 oxidation number and chlorine atom has -1 oxidation number. We can find out the total oxidation number of atoms in sodium chloride. We can add the oxidation number of sodium and chlorine atoms, +1, -1, +1 and -1 equal to 0. We can say that the total oxidation number of atoms in sodium chloride is equal to 0. We can have some more examples, that is one example is calcium chloride. Calcium has a +2 oxidation number and chlorine atom obviously has -1 oxidation numbers. Now we can calculate the total oxidation number of atoms in calcium chloride. There is only one calcium atom. I put its oxidation number +2. There are two chlorine atoms. I put 2 bracket. The oxidation number of chlorine atom is -1. Now we can do the calculation here. +2 and 2 1 is 2, we get -2. +2 and -2 is equal to 0. We can say that the total oxidation number of a neutral compound calcium chloride is equal to 0. We can have one more example, that is sulfuric acid H2SO4. Hydrogen obviously has a +1 oxidation number, sulfur has +6 oxidation number, and oxygen of course has -2 oxidation numbers. Now we can calculate the total oxidation number of atoms in sulfuric acid in H2SO4. There are 2 hydrogen atoms. I put 2 bracket. The oxidation number of hydrogen atom is +1. I put +1 plus. There is only one sulfur atom. I put its oxidation number +6 plus. There are 4 oxygen atoms. I put 4 bracket. The oxidation number of oxygen atom is -2. We put here -2. Now we can do the calculation here. 2 1 is 2, we get +2 we have plus 6, 4 2 is 8, we get minus 8. Well, plus 2 and plus 6 make plus 8, and see, this side we have minus 8. Plus 8 minus 8 is equal to 0. Here we can say that the total oxidation number of atoms in sulfuric acid is 0. Well, the next rule is the total the oxidation number of group first A elements in a compound is always plus 1. The group first A elements are lithium, sodium, potassium, rubidium, cesium and francium. These are first A group elements. If any of these elements are present in a compound, they always show plus 1 oxidation numbers. For example, you can have lithium chloride. In lithium chloride, lithium is a first A group element and it shows plus 1 oxidation numbers. We can have some more examples. Lithium carbonate, lithium shows plus 1 oxidation numbers. You can have sodium sulfide and it shows plus 1 oxidation numbers. We can have sodium carbonate, sodium shows plus 1 oxidation numbers. We can have potassium oxide, potassium shows plus 1 oxidation number. Here we can say that if any of these first A group elements are present in a compound, they always show plus 1 oxidation number. Well, the next rule is the oxidation number of group second A elements in a compound is always plus 2. Second A elements are beryllium, magnesium, calcium, strontium and barium, and here we have radium. Well, any of these elements are present in a compound, they show plus 2 oxidation number. We can have some example. For example, beryllium oxide, B shows plus 2 oxidation numbers, and magnesium carbonate, Mg shows plus 2 oxidation numbers. Magnesium sulfate, Mg shows plus 2 oxidation numbers, and so here we can have one more example, calcium hydroxide, calcium shows plus 2 oxidation numbers. Well, here we can say if any of these second A elements are present in a compound, they have plus 2 oxidation numbers. Well, the next rule is the usual oxidation number of group 7A elements in a compound is minus 1. 7A elements are halogens. Halogens are fluorine, chlorine, bromine, iodine and astatine. These are 7A elements. Well, if any of these elements are present in a compound, they show the usual oxidation numbers minus 1. We can have example hydrogen fluoride, fluorine gas, fluorine fluorine atom shows minus 1 oxidation numbers. In sodium chloride, Cl atom shows minus 1 oxidation numbers. We can have magnesium chloride, Cl shows minus 1 oxidation number. We have aluminum bromide, Br shows minus 1 oxidation number. There is one exception. If any of these halogens are combined with more electronegative atom, obviously fluorine atom is an atom which is the most electronegative atom present in the periodic table. For rest of the halogens, if they are combined with more electronegative atom, they show plus 1 oxidation number. For example, in HOCl, Cl is combined with oxygen atom. Oxygen is more electronegative than Cl atom, that's why Cl shows plus 1 oxidation number. This is one exception, and so the usual oxidation number of group 7 elements for these elements is minus 1 in most of the compounds. Well, the next rule is the usual oxidation number of oxygen atom in a compound is minus 2. We can have some examples. For example, a water molecule, oxygen has minus 2 oxidation numbers. In sulfuric acid, H2SO4, oxygen has minus 2 oxidation number. In nitric acid, oxygen has minus 2 oxidation numbers. We can have one more example. magnesium oxide, oxygen has -2 oxidation number. There are few exceptions in which the oxidation number of oxygen atom is different. For example, in peroxide, the oxidation number of oxygen atom is -1. Here in hydrogen peroxide, oxygen has -1 oxidation number. In barium peroxide, oxygen has -1 oxidation number. And if in case oxygen atom is combined with highly electronegative atom, that is fluorine atom, it shows +2 oxidation number. In oxygen fluoride, oxygen shows +2 oxidation number. These are few exceptions, and the usual oxidation number of oxygen atom is -2. Well, the next rule is the total oxidation number of an ion or polyatomic ion is always equal to its total charge. And ions, you can have sodium ion, it has +1 charge. We can have calcium ion, it has +2 charge. Aluminum ion, it has +3 charge. We have chloride ion, it has -1 charge, and we can have sulfide ion, it has -2 charge. These are individual ions. And the polyatomic ion are the ions which are made up of more than 2 atoms. For example, sulfate ion, it has -2 charge. Cr2O7, it has -2 charge. We can have one more polyatomic ion, that is MnO4, and its total charge is -1. Well, the total oxidation number of an ion or polyatomic ion is always equal to its total charge. Sodium has +1 charge, that is why its oxidation number will be +1. Calcium has +2 charge, that is why its oxidation number will be +2. Aluminum has +3 charge, that is why it has +3 oxidation numbers. And same case goes with chloride ion, it has -1 oxidation number equal to its charge. And similarly, sulfide ion has -2 oxidation numbers. And same concept applies with polyatomic ions. SO4 has total charge -2, that is why its total oxidation number will be -2. Similarly, Cr2O7 has -2 oxidation number equal to its total charge. And the same case goes with MnO4, and it has -1 charge, that is why its total oxidation number will be -1. The last rule states that the oxidation number of hydrogen atom with a metal is -1. If hydrogen atom is combined with a metal, it shows -1 oxidation number. We can have sodium atom is a metal and it is combined with hydrogen atom, hydrogen shows -1 oxidation number. We can have some more examples. Calcium hydride, hydrogen shows -1 oxidation number, because calcium atom is a metal. Aluminum, in aluminum hydride, hydrogen shows -1 oxidation numbers. Well, if in case hydrogen atom is combined with a non-metal, it shows +1 oxidation numbers. For example, hydrogen chloride. Cl atom is a non-metal, that is why hydrogen shows +1 oxidation numbers. In a water molecule, oxygen is a non-metal, to which hydrogen atom is combined with, hydrogen shows +1 oxidation numbers. Well, we can have one more example, that is ammonia molecule. And nitrogen is a non-metal, that is why hydrogen shows +1 oxidation number. These are certain rules which we follow to assign the oxidation number of an atom, to find out whether the atom is being oxidized or reduced in a chemical reaction.